Hey everyone, in this video we're looking at assignment 20 in class, the Logs and Exponential Review worksheet. Show all work on separate paper. Okay, that'll be my whiteboard. Tell whether each represents exponential growth or decay. So problem, well, this one's dying, so I'm not going to use that. I'll use blue today. Okay, 1. F of x equals 1/2 5/7 to the x. Because the base is between 0 and 1 and there's no negative here, I know that this is decay. Okay, and the next one, 2, f of x is decay. Write a sentence. F of x equals 1/3 7/5 to the x. Well, because this is bigger than 1, I know this is growth. Because the base is greater than 1 because b is between 0 and 1. All right, and 3, f of x equals 3 times 4 to the negative x. Well, while it's true that b is greater than 1, I see this negative up here, and that's going to mean that this is decay because of the b is greater than 1 and the negative in front of x. Okay. 4, summarize how you can tell if an exponential function is growth or decay. All right, so if b is between 0 and 1, and there's a no negative, no, and x has a positive coefficient, then this is exponential decay. And if b is between 0 and 1 and x has a negative coefficient, then the function is growth. But if b is greater than 1 and we have a positive coefficient on x, we have growth. And finally, if b is bigger than 1 and we have a negative coefficient on x, we have, then this is decay. Okay? 5, graph without a calculator. Okay. And we've got what looks like 7 of these, 8 of these. So 5, f of x equals 3 to the x. Well, this is just our exponential reference graph. It's not been shifted up or down or stretched left or right. It's just the basic graph. So really, I just need the reference points. -1, 1 over b, 0, 1, and 1, b. Okay? 6, f of x equals 3 to the x plus 2. Well, that's my 3 to the x shifted left 2. Yes, I would like to see some work. I do want to see these things. Because look, remember, this is AP Calculus. And in AP Calculus, it's not calculus, it's AP Calculus, your work is going to be read by probably 6 different high school and college calculus instructors. And so the only way they'll know you know calculus is if you show them the work. If you just put down the answer, you get no points. No points, even if the answer is right. That's called a bald answer. No supporting work. So please get in the habit of showing the work, okay? So we've got -1, 1/3. We've got 0, 1, We've got 1, 3. And don't forget our horizontal asymptote is y equals 0. So I'm on the lookout for something that would shift that too. I do see here only one transformation, subtracting 2 from all the x's. So the points that I need to graph are negative 3, 1/3, negative 2, 1, and negative 1, 3. The horizontal asymptote is still at y equals 0. And then I'm doing exponential growth. I've got negative 3, 1/3. I've got negative 2, 1, and negative 1, 3. Okie doke, doink, and doink. There's number 6. How about 7? Oh, it's the 3 to the x graph, but this time there's a vertical transformation. 7. F of x equals 3 to the x plus 2 on the outside. So if I start off with the reference points, negative 1, 1/3, 0, 1, and 1, 3, then y equals 0 would be the horizontal asymptote. I have to apply this y transformation to all my y's. So I end up with negative 1, 2 1/3, 0, 3, 1, 5, and y equals 2, the horizontal asymptote. What's the graph look like? Well, no. Sorry, could live a noob for a second. Y equals 2 here. We've got exponential growth. So this is 0, 3, 1, 5, and back here, negative 1, 2, and 1/3. Okie doke. Okay, how about problem number 8? 8 says f of x equals log base 3 of x. Well, again, that's a reference graph. My points are 1/b negative 1, 1, 0, and b 1. Don't forget we've got x equals 0, a vertical asymptote for all our log graphs. So what does this look like? Well, vertical asymptote at x equals 0, characteristic log shape. Here's 1, 0, here's 3, 1, and here's 1/3, negative 1. Problem 9 is a transformation. F of x equals log base 3 of x plus 2. So we're going to have 1/3, negative 1, 1, 0, 3, 1, and don't forget x equals 0, the vertical asymptote. I bring that up because I see I'm supposed to subtract 2 from all the x's, including that one. Oops. I swear, this gets left out so often by students that even when that's there and even when they put them here, they still make the vertical asymptote here and then they end up with the wrong graph. So please be mindful of that. Okay, so I've got negative 5/3, negative 1, negative 1, 0, and 1, 1. X equals negative 2 is the vertical asymptote. Negative 6/3 is negative 2, so this is to the right of that vertical asymptote. So what does this graph look like? Well, we've got our vertical asymptote at x equals negative 2. We have our characteristic shape with negative 5/3, negative 1, negative 1, 0, and 1, 1. So here's my y-axis. I'm sorry, my x-axis and my y-axis would be here somewhere. Okay, that's 9. How about 10? 10 is that vertical transformation. F of x equals log base 3 of x plus 2. So I add 2 to all the y's. Remember, my reference points are 1/3, negative 1, 1, 0, 3, 1, and don't forget, logs have x equals 0, the vertical asymptote. Okay, so I see only one transformation to add 2 to all the y's. That's not a y, so I don't add 2 to that. And my graph, vertical asymptote at x equals 0, characteristic log shape passing through 1/3, 1, 1, 2, 3, 3. So here I have 1/3, 1, I have 1, 2, and I have 2, 3. Excellent. And what about problem 11? Well, now we're switching to ln, and I'm okay with graphing f of x equals ln of x using exact values. Vertical asymptote at x equals 0, characteristic log shape. This is 1, 0. This is e1 because this is log base e of x. And so this would be 1 over e negative 1. And like I said in a prior video, if you want to decimalize this and give me e to 3 places, 2.718, 2.718, comma 1, and you want to say down here that 1 divided by e is 0.3679, comma negative 1. You can do that, but you're either going to have to memorize these or it's going to have to occur on a calculator portion of the test. And if I give you this on the non-calculator portion of the test, then the only option you have is to memorize these or just use the reference points and not sweat it. Okay, our last graphing problem, number 12. Oops. Number 12 is another ln. It's f of x equals 4 minus ln of x minus 2. Now, I find that students are much happier when they use the commutative property of addition here, right? So we've got this object and we've got this object, okay? Well, actually, this object. And we're adding those two objects together. You know, that middle school teacher tried to say to you, hey, a equals b is same as b equals a. And you were all, yeah, duh, of course. But what we need to take away from that, the reason they were trying to teach you that is I could flip these two. Negative ln of x minus 2 plus 4. In this form, I find students have a much easier time with it. So my recommendation is that you, in fact, switch it around. There's a positive 4, there's a negative in front of the ln. We have to preserve those. But now I see the two y transformations. I need to multiply the y's by negative 1 and then add 4 to them. And at the same time, I'm going to add 2 to the x's. So what's our log base? Well, we've got 1 over e negative 1, 1, 0, and e1. And because I'm lazy, I'm just going to work with the e's and not sweat it. I'm going to add 2 to all the x's, including x equals 0, our vertical asymptote. And in the meantime, I know that I have to multiply the y's by negative 1. And so my transition points are going to be 1 over e plus 2, oops, plus 2, comma 1, 3, 0, and e plus 2, negative 1. Okay? Remember, this has got a negative out front, and that negative out front reflects the graph. Okay, so my high point is on the left side, my low point is on the right side. All right, but wait, there's still one more transformation. I still have to come back and add 4 to all the y values. And so I'm going to end up with these points, 1 over e plus 2, comma 5, 3, 4, e plus 2, comma 3, and x equals 2 is our vertical asymptote. So let's sketch what we know. Remember, it's this shape flipped upside down because of that negative. And so I'm looking at something that will have a vertical asymptote at x equals 2, but then we'll do this. Okay, and so this point over here, 1 over e plus 2, 5, and this point here, 3, 4, and this point here, e plus 2, comma 3. Okay, if this is the calculator portion of the test, you're more than welcome to decimalize these. If it's the non-calculator portion of the test, yeah, I need to see that. Okay, problem 13. 13 says, rewrite the equation in exponential form. Okay, log base 2 of 1 equals 0. And this is our opportunity to use our fond old scorpion tail. And so that's going to be 2 to the 0 equals 1. All right, and if I have 14, log base 2 of 1/8 equals -3, and I use my scorpion tail again, base, power, answer. 2 to the -3 equals 1/8. 15, we've got log base b of x equals y. And when I do scorpion tail here, you know, it's base, power, answer. So it's b to the y equals x. All right, 16, evaluate without a calculator. Log base 3 of 27. Well, I know that's the same as log base 3 times 3 times 3, and that's going to be the same using the product rule. Log base 3 of 3 plus log base 3 of 3 plus log base 3 of 3, which is 1 plus 1 plus 1, or 3. So that's one way to do the problem. I would probably do the problem like this, where I said log base 3, 27 is 3 to the third. And then I say, oh look, an exponent with a log. So I can bring that down using the power rule. 3 log base 3 of 3. I know log base b of b is 1, so this is 3 times 1, or 3. Okay, there's 15. I'm sorry, was that 16? That was 16. 17. 17 says, log base 5 of 5 to the 2/3. Well, excellent. We were just talking about this. Let's use our power rule. 2/3 log base 5 of 5. And what's log base b of b? Well, that's 1. And so our answer here is 2/3. So if I'm really keen on writing sentences, is 2/3. 18. 18 says log base 2 of 1 over 64. Okay, so, you know, I could do two things with this. I could split this up into log base 2 of 1 minus log base 2 of 64, because I could use my quotient rule. 2 logs joined with subtraction can turn into 1 log, where those things are joined with division. And then I could simplify here and say log base 2 of 1 is 0, minus log base 2 of 2 to the 6th. I could bring that 6 down in front to get log base 2 of 2. And then I say, oh, log base 2 of 2 is 1, and 1 times -6 is going to be -6. So that's one way to approach the problem. Another is to come over here and say, well, this is the same as log base 2 of 64 to the -1. And then we could say log base 2, 64, well, that's 2 to the 6th. And then I can raise a power to a power. And so I've got log base 2 of 2 to the -6. I'll use that power rule to bring down the -6. And that's going to be -6 times 1, or -6. Okay, there's 18. 19. Find the inverse of each. F of x equals ln of x plus 3. Well, you know, most students find it easier to do this problem if we write y equals log base e of x plus 3, because they know they're supposed to switch the x's and y's. And then solve for y. So I'm going to subtract 3 from both sides and have x minus 3 equals log base e of y. Now I have to free that y from the clutches of log base e. And we can do that with the powerful spell called exponentiate. The base here is e, so I'm exponentiating with e. So my answer then is y, or f inverse, because this is the inverse, equals e to the x minus 3. Remember, all this was here when I exponentiated, so all this is up in the exponent. Okay, there's 19. How about 20? 20, f of x equals log base 4 of 16x squared. All right, so let's change that to y equals. Let's switch the x's and y's. Oops, switch the x's and y's, so that's got to be a y. And let's do some stuff. Well, I can't get at any of this stuff until I get rid of the log. So I'm going to exponentiate with 4 on both sides. I have 4 to the x equals 16y squared. Okay, I have to undo this squaring. Well, that's square root, or raising both sides to the 1/2 power. So now I've got 16y on the right-hand side, and on the left-hand side, when I raise a power to a power, I multiply them. So I have 4 to the x over 2, or if you prefer, 1/2 x. Okay? Now, I have a question for you. What about the plus and minus? Didn't we just take the square root of both sides? Shouldn't there be a plus or minus? Yeah, so you can either go with the plus or minus, or because it's, well, it can't be a plus or minus, can it? Let's take a look at this original graph. So, we've got ln of 16x quantity squared divided by ln of 4. So I use the change of base formula to get it into my old calculator. Okay, and standard should be fine. So that's the function. It looks like a regular log. And one thing to think about, that's very interesting. If I plugged a negative in here, I'd have negative 16, and that would be squared. And so then I'd have a positive. I'm taking the log of a positive. So why can't I plug negatives in there? Huh. Let's see what the table says. Negative 2. Yeah, you don't like that. Did I type this in properly? ln of 16x squared. Second insert parentheses. Second insert parentheses. I didn't have enough parentheses. Yeah, so it is a plus or minus situation. So make sure you have that plus and minus on this. Okay, so we need this plus and minus, and then we divide by 16. Now, you know, a curious thing about the AP Calculus exam, specifically in the multiple choice, they often wouldn't leave the answer like this. So they would often do something like this. They would say, oh, 4, that's 2 squared, raised to the 1/2 x, all over 2 to the 4th. And then they would say, when I raise a power to a power, I'm multiplying them, and so I end up with 2 to the x over 2 to the 4th. But wait, I'm dividing and the bases are the same. And so what can I do with those exponents? Subtract them. So that's the answer I'm going to see in multiple choice, not this. This is correct. Ooh, plus and minus. Don't use that. This is correct, but it's not simplified. So while I'm not going to require you to go through this simplification, I'm definitely warning you to be prepared for, okay, I got this answer, but I don't see it as one of the choices. Okay? All right. So that was 20. How about 21? 21 says f of x equals 2 log base 4 of x minus 3. Okay, well, this should be a little more humane. I'm going to switch my x's and y's and have x equals 2 log base 4 of y minus 3. Now I can't exponentiate yet until I get rid of that 2. I'm going to divide both sides by 2. And now that I have this log base 4, I need to exponentiate with 4 on both sides. So now I've got 4 to the x over 2 equals y minus 3. And all I have to do is add 3 to both sides. So 4 to the x over 2 plus 3 equals y. Again, this is fine for our test, but this is 2 squared. And when I raise a power to a power, I multiply them. So these would cancel, and I would just have 2 to the x is my inverse. Okay? Okay. Oh, don't forget that 2 to the x plus 3. Good catch, Nathan. All right, where are we going next? Solve the exponential and log equations. Okay, 22. I've got e to the 2x equals 42. Well, I know what gets rid of e to the, what will allow me to bring this exponent down is if I take the log of both sides, or in this case, log base e or ln of both sides. Because now I can bring this down and have 2x. 2x comes down, and ln of e equals ln of 42. Now we know, or we really should know by now, that the ln of e is 1. So we've got 2x equals ln of 42, or x equals 1/2 ln 42. Okay? 23. Oh, this is not a must check because this is an exponential equation, so I don't have to worry about must checking. Exponential equations have an unrestricted domain. It's the log equations that are must checks, or if I square both sides. Okay, so now we're looking at 3 to the 2x minus 3 equals 4. Let's add 3 to both sides. And now you could take the log base 3 of both sides, but I'm going to take the ln of both sides so that I can bring this down. 2x ln of 3 equals ln of 7. And then remember, I'm trying to get x by itself, so I've got to get rid of the 2, and I have to get rid of the ln of 3. And so we end up with x equals ln of 7 over 2 ln of 3. You cannot combine these into one ln. You can combine these into one ln, but you can't combine these, nor can you cross them out. Those are 2 common mistakes. Watch out for it. Okay, and again, we're starting with an exponential, so I don't have to worry about must checking my answer. 24. 24 says 3 to the 3e to the negative x equals 18, or e to the negative x equals 6. When we take the ln of both sides, we get negative x equals ln of 6, so x must be negative ln of 6. I mean, I guess you could always kick that negative up there, power rule in reverse, and then that could be written as ln of 1 over 6, but I would probably stop here. And so, remember, write a sentence, x is. Okay? So there's 24. How about 25? 25 says 3/8 times 2 to the 3x plus 1 equals 10. So let's subtract 1. Let's multiply both sides by the reciprocal. So we've got then 2 to the 3x equals 24. And now I'm going to take the ln of both sides. Again, you're welcome to do the log base 2 of both sides and bring that down. So where am I now in this problem? Well, now it should say 3x ln of 2 equals ln of 24. I want to get x by itself, so I have to divide by 3 and ln of 2. So 3 ln of 2. So x equals ln of 24 over 3 ln of 2. All right, that was 25. How about 26? Another exponential. 26. Negative 3 e to the minus x minus 4 equals negative 13. Okay, I'm going to start by adding 4 to both sides. So my next move would be negative 3 e to the minus x equals negative 9. And then I would divide both sides by this negative 3. So we get e to the x equals 3, because negative divided by negative is positive. And now I need to take the ln of both sides. So that I can use the power rule to bring this down. And I get negative x equals ln of 3. And so I know that x is negative ln of 3. Okay, think about this in terms of transformations. Think about this graphically for a moment. So this is my exponential decay curve, but this is that curve flipped upside down, right? So I've got my exponential decay curve. That's this piece. But now I'm going to flip that graph upside down. And then shift the graph down 4 places. So this is y equals negative 4. And I'm asking, where does this graph intersect the line y equals negative 13? And the answer is over here at negative ln of 3. Okay? So, how about 27? 27, ooh, it's a log equation. 27 says log base 2 of x equals 1.5. I'm going to go with 3/2. All right, so I need to exponentiate, and I get x equals 2 to the 3/2. Yeah, well, I wouldn't do anything with it, but I do know that's 2 to the 1 plus 1/2. And so that's going to be 2 to the 1/2 times 2 to the 1, or 2 square root of 2. So this is the same as that. And I don't think you need to worry about that, but I did think you should see that at this moment, okay? All right, that's 27. Oh, what can't I have inside of a log? What's in parentheses can't be 0 or negative. Is this 0 or negative? No, so I'm good to go on this one. How about 28? 28, we have negative 5 plus 2 ln of x equals 5. So I'll add 5 to both sides. I'll divide both sides by 2. And then I'll exponentiate. So x equals e to the 5th. The only things that I can't have here inside those parentheses, I can't take the ln of 0. I can't take the ln of a negative number. Is e to the 5th a negative number? Well, remember e is 2.718, and I'm raising 2.718 to the 5, and that's definitely going to be a positive number. Okay, so I don't have to worry about checking that one. How about problem 29? 29 says log base 2 of x plus 2 equals log base 2 of 3x. Well, I exponentiate on both sides with 2. And so now I've got x plus 2 equals 3x. Subtract x from both sides, or x equals 1. If I plug a 1 in here, that's the log of 3. That's okay. If I plug a 1 in here, that's the log of 3, and so that's okay. So that's my answer. X is 1. Okay, that was problem 29. How about 30? 30, our last solving one, says log base 2 of 2x plus 1 equals 4 plus log base 2 of x minus 4. Now be careful, because remember, you can't do that. That's wrong. Don't do that. You can exponentiate the whole side of the equation. And so I guess what I really want to do is I want to move all the logs onto one side and then apply my log properties. So log base 2 of 2x plus 1 minus log base 2 of x minus 4 equals 4. So I've moved the logs over, and then I see two logs joined with subtraction. So my quotient property for logs says I can rewrite this way. And it's only at this point that I can exponentiate. Okay? Exponentiate the whole side of the equation. So I've got to condense down into one object. Okay, so I'm going to have 2x plus 1 over x minus 4 equals 2 to the 4th, or 16. I'm going to multiply both sides by this denominator, x minus 4. These will cancel. I'll have 2x plus 1 equals 16x minus 64. Let's move the x's to one side and the numbers to the other. And so I get x equals 65 over 14. Now, that's, excuse me, 4 times 14 is 56, and 5 times 14 is 70. So I know that this is between 4 and 5, this number. When I divide 65 by 14, I get a number in between 4 and 5. Well, what's going to happen here? So 4 is 56 fourteenths, right? So I've got 65 fourteenths minus 56 fourteenths. Yes, that's still a positive number. And over here, I'm going to get a positive number as well. And so I feel pretty confident with this. X is 65 over 14. All right, now in 31 and 32, we're asked to expand. We just did some condensing. Now we're asked to expand. 31 says log base 2 of x over 5. And so one log that has division inside of it can be split into two logs joined with subtraction. And 32, we've got log base 5 of square root of x times y times z. Well, I see my product rule here, so I can split this up into square root of x plus log base 5 of y plus log base 5 of z. And many students stop here, but we're not done yet because we have this exponent to deal with. Remember, square root of x is the same as x to the 1/2. So I have to use that power rule and bring it out in front. 1/2 log base 5 of x plus log base 5 of y plus log base 5 of z. Okay, that's my answer. And if you wanted a sentence, I'd say is the expanded form of log base 5 of square root of x, y, z. Okay? 33. Ooh, condensing now. Let's have some specific condensing practice. 33 says log base 3 of 7 minus log base 3 of x. Well, that's my quotient property, and I know I can rewrite that as log base 3 of 7 over x. 34, log base 4 of 5 plus log base 4 of x plus log base 4 of y. Well, there's my product rule, so this is just going to be log base 4 of 5xy. Well, it's not a big deal. This is an easy review. 35 says 2/3 log base 2 of x minus 3 log base 2 of y. So before I can deal with that, I have to deal with these. I have to kick these coefficients back up as powers. Okay? So my next step will be log base 2 of x to the 2/3 minus log base 2 of y cubed. Two logs joined with subtraction allows me to write this as log base 2 x to the 2/3 over y to the 3rd. Okay, there's 35. So next, what are we doing? 36. Ooh, a word problem to end on. That's great. 36. We're given a formula, the amount as a function of time, 25.85 to the t. And notice, this is a capsule of medicine. This is our initial dose of medicine. And notice here, this is 1 minus 0.15 to the t. So the amount of medicine is decreasing by 15% per hour. Oh, look at the questions. There we go. Part A, the initial amount is 25 milligrams. Part B, what's the percent that leaves the body each hour? 15% leaves the body each hour. Remember, I'm using A equals P, 1 plus or minus R to the T to come to that conclusion. What makes 0.85 is 1 minus 0.15, and so that must be how much is leaving. This is how much remains. 100% minus 85% gives me that 15% leaves. What's the amount in the body after 10 hours? Okay, so part C, we're looking for A of 10. That's 25.85 to the 10. Remember, PEMDAS says you have to do this exponent before you multiply by 25. So if I do 0.85 raised to the 10, and then multiply that number by 25, we've got, after 10 hours, 4.922 milligrams remain. Okay? And our final question, when will the amount of medicine in the body be less than 1 milligram? Well, that's me saying, when does A equal 1? We're supposed to find the time. So 1 equals 25.85 to the t. 1 over 25 equals 0.85 to the t. If I take the ln of both sides, I can bring that power down and say that t equals the ln of 1 over 25 divided by the ln of 0.85. And, to go any further, I'm going to need to pull out my calculator. ln 1 divided by 25 divided by ln of 0.85. And I get t is approximately 19.806 hours until only 1 milligram remains. Okay? But, since I had to pull out the calculator, I don't know that I would do all this algebra. I think I would be inclined to graph 25 parentheses 0.85 to the x in y1, and then in y2, graph the line 1, and set up a viewing window. No negative time is needed. Steps of 2. And my y values, well, my y min is 0 in the body. My max is 25 in the body in steps of 2. Oh, so close. I need to make my x's go further over, and I probably don't need all this y. So let's go out to 30 in steps of 3, and let's change the y's to, 5 in steps of 1. There's our exponential decay curve, 25 times 0.85 to the t. Second, calculate, intersect, boink, boink, boink. And I end up with 19.9, no, 19. 8:06 hours. So I can get that same answer. And, if it's a calculator active question, I'd use the calculator. I think one of the most challenging things for students in this class is that they want to do everything algebraically by hand. But if we're on the calculator portion of the test, use the damn calculator. All right. Well, that's it for this worksheet. I hope this was helpful and you got the answers you were looking for. Perhaps you'll watch the next video, which is Trig Reviewed, Assignment 20 homework. Okay, take care.